I don't think we've had a problem exactly like number 1 before, but it's all things that you should be able to do. Also, the reason that it's on the review is because I was nervous that because we hadn't seen one exactly like that before, I was worried about how that was going to go. So, we want to find all 6 trig values, so that means we want sine, cosine, tangent, but we also want cosecant, secant, and cotangent. So the first thing I did is I thought about, well, what does tangent mean? Like all the way back to, I don't know, middle school maybe, when you first learned SOHCAHTOA. So sine is opposite over hypotenuse. So I kind of dismantled my fraction and I said, okay, here's my opposite, here's my hypotenuse. And then I still need to know my adjacent side. So I plugged into Pythagorean theorem to solve for the adjacent side, which I just called B for lack of a better name. So I knew all 3 pieces. I knew opposite was root 5, hypotenuse was 3, and adjacent was 2. And then I just plugged them in. So for I already had that. For cosine, that's cos, so adjacent is 2, hypotenuse is 3, so 2 over 3. Tangent is TOA, so opposite was root 5 over adjacent was 2. And then to get the cosecant, secant, cotangent, we don't have a nice little like SOHCAHTOA thing, but we know that they're reciprocal buddies. So I just took this and took the reciprocal and rationalized. Took the reciprocal, and rationalized. Are we okay with that problem? Like I said, we've seen components of that problem, but probably not all together like that, and that's why I wanted to make sure we had one of those on the review. Number 2, the formula that you want to use. So the formula that was in my head that I was using was x squared plus y squared equals 1. She was good with it, right?
Yeah.
In case I have to send somebody else. Okay, thank you. So the formula is x squared plus y squared equals 1. That is the equation for our unit circle, centered at the origin with a radius of 1. So when I plug in x and square it, I get 4 over 49. And then when I subtract it to the other side, I would get 45 over 49. And then I reduced it. And it looks like I didn't even simplify it very much. I don't love that answer. Let me actually go further on that one, because that's not my final answer the more I look at it. Why isn't that my final answer?
Because it can be the top number can be
Yeah, we got to keep going. That is not my final answer. So I can do, for the top, I can do 9 times 5 over 7. And we know that would be 3 root 5 over 7. So y equals, that's a better answer. This one was close, but not quite there. So it will be root 45 over 7, but then you have to go a step further and simplify. And again, if this had been me on the test and this was my answer on my page and I went to look at the multiple choice, it's not going to be there, right? It's always going to be the most simplified. So be careful, and if your answer isn't there, think to yourself like, hey, did I not simplify it enough? And that would have been my issue here. Put that up there. Questions on 1 or 2 before we move? We're good? Make sure you draw yourself a unit circle if that would help you on the exam. The other thing you could do, instead of drawing the whole unit circle, if you don't have quite that much space to budget, remember you could always draw just quadrant 1 of the unit circle and then think about your reflections. So even if you have just enough room for one of the quadrants, I think maybe that'd be worthwhile to have. The reference number, remember it's the fastest way back to the x-axis. 7 pi over 4 is located where I drew the dot with the little line. And so how much further to get to the x-axis? I could go pi over 4 forwards, or I could go backwards, kind of in my negative direction, 3 pi over 4. So the faster would be pi over 4. Remember, your reference number is always positive. So think about like process of elimination and other stuff that you can do because it's multiple choice. If there were any negative answers, you could scratch them off from the beginning, right? So think about things like that that you can do to help yourself. Find the point on the unit circle determined by negative 5 pi over 3. So I found the point and wrote it down. I rotated, again, the negative direction. Questions on 3 or 4? And again, even if you know the unit circle really well, like we talked about before, remember that the testing environment is different when it's an exam, right? And you might be a little bit more anxious. And so maybe on a normal day, you don't need part of the unit circle on your note card, but maybe for the exam, just because there's so much going on, maybe having that first quadrant might be nice. So just a thought. You don't have to. Obviously, I'm not going to force it. Oh, I never even graphed number 7. Great. Okay, cool. So let's look at 5, or no, just kidding. No, yeah, 5, 6, and 7. Let's look at all 3. So for number 5, I wanted to find the exact value, so I rotated to the location. For sine, I looked at my y value. For secant, I looked at my x, and then I took the reciprocal, and then I rationalized. Make sure you rationalize your numbers. Again, that'd be a situation where if you didn't, you'd look for your answer and it wouldn't be there. It'd be close, but that answer wouldn't be there. So make sure you rationalize. For number 6, it should be an even graph. For number 7, I never graphed it. I'll show you the graph in just a second. The period is 2 pi. So for both the secant and the cosecant, the period is 2 pi. Do you remember the trick with graphing the cosecant and the secant? Is there a button for that? Sort of, I guess, is the answer, right? So when I go to plug this in, I would plug in 0.5 for my 1/2. This is the same as 1 let's put a times. This is the same as 1 divided by sine x. And then I would hit graph. Do you remember our graph friends that look like this? And we would just find the mins and maxes. And remember, could you truly graph this out in the test? Like, is there a spot for you to graph? No. You're going to be given the equation, and you're going to be asked which graph matches. Yeah?
Number 6, why is it even?
Number 6, why is it even? Oh, because if you're graphing the cosine function, it looks like this, and it continues out, and it's a reflection over the y-axis.
Okay.
So anything that is a reflection over the y-axis is even. Point symmetry to the origin is odd. So like the cubic graph that goes like that, that would be a good example. Alright, so secant and cosecant look very similar, remember? Okay. The period is 2 pi for everything except tangent and cotangent is pi. And then even within those, you could drill in further, right? Because it's really 2 pi over k. So there are times where those would even change. But for the most part, our cosecant and secant, the period is 2 pi. All right, last little itty bitty bit down at the bottom. And your packet should be filled out now at this point. If they're not, I have mine, and you're welcome to come look at it and take a picture, do whatever you need to do to get it filled out. The videos are also all online, so you can look there as well. Remember where your no-fly zones are for problems like number 8. Remember when you have inverse, sine, cosine, tangent, is that it wouldn't give us a function unless we limit the domain. So we limited our domain. So for cosine, we could only live on the top part of the unit circle in quadrants 1 and 2. So where does this happen? It would happen at pi over 4. And then what's the cotangent there? It should be 1. Because when you divide, listen, when you divide your y over x, you should get 1. Or x over y. Either way, because it's the reciprocal, but it'll be the same. Okay, be comfortable to do problems like 3 and 4 with values bigger than 2 pi or smaller than negative 2 pi. Usually those are the ones that bother people when it's a really big value, so bless you. Make sure you divide in and you think about what the mixed number would be. Be super comfortable with your unit circle. If you're not, then it would go on my note card. Okay? And maybe even if you are, if you think it'll take off some anxiety, then maybe it goes on there for that reason, even if you know it. Be comfortable with knowing this says amplitude. Would you be able to find the amplitude? Remember, the only graphs that have amplitude are sine and cosine. The rest of them don't have that. Do you remember the amplitude is the number out front of everything? So for example, if you had y equals 3 cosine of 4 theta. Okay, let's pretend this is our problem. You ready? Let's talk amplitude. What's my amplitude? 3. If you're looking at the graph, it's half the distance between the min and the max is another way to find it. The period is 2 pi over k, so 2 pi over 4. So this would be pi over 2 for my period. So if pi over 2 is my period, then what would my frequency be? Remember how to find that? How do I find the frequency if I know the period? It would be 2 over pi. Okay, so make sure you know how to find those things from the equation. And again, the only ones that have amplitude are sine and cosine. The rest we can find period and frequency, but the only ones with amplitude are sine and cosine. What do you have for me before we go over homework? Any questions on this stuff? Yeah?
How do you do the questions where there's a phase shift and a period change?
Phase shift and a period change. Remember, that's when we factor stuff out front. So that would be something where you have, let's see, cosine of, let's say, 2x plus pi over 4. Let's say this is what you had to start with. That's what you're asking, right? Okay. So what I would do is I would pull out the 2, and then you're almost thinking backwards, because whatever you have here, you would have to multiply it and have it come out to pi over 4. So I'd actually need a pi over 8 inside, because if I had 2 of those, it would be the same as pi over 4. So this one, my k value would be 2, so 2 pi over k, so it would just be pi. And this one would be a phase shift to the left by pi over 8. Good? Alright, take out homework. I'll stop the video.